Alright, so this is question 2 from the 2017 VCAA Chemistry exam. This is, again, me going through from start to finish the exam papers and looking at each question and looking how, I guess, the tips and tricks for answering exam style questions for chemistry. So this question, I'm going to go quickly, first of all, not even read this, I'm going to look at this. It's talking about petrodiesel and biodiesel, so that's pretty good. This is just giving us a bit of an intro to that, I'm guessing, as well. So a vehicle that is powered by a diesel engine is able to use either petrodiesel or biodiesel as a fuel. Petrodiesel and biodiesel are not pure substances, but are a mixture of molecules. In general, petrodiesel consists of molecules that are shorter in length, on average, than those found in biodiesel. Petrodiesel contains molecules that include functional groups. So giving you a bit of background into the molecules that you already have an idea about it anyway. Now here's a question. Describe and explain the difference in viscosity under the same conditions. So difference in viscosity under the same conditions of the two fuels and how this would affect the flow of each fuel. Now this is worth 3 marks and this is a describing question. So the first thing I'm going to do, now I know it's worth 3 marks, so I'm going to put 3 dot points here. Dot points are awesome in exam questions because they make sure that you actually hit all the marks and can try and answer. Your answer actually has 3 distinct points that can be awarded marks here. So first of all, it's talking about biodiesel and petrodiesel. You should have an idea about their viscosity already, and you should know that biodiesel has a higher viscosity than petrodiesel. Alrighty, so that's your knowledge from your content there. Now, so under the same conditions, that's correct, of the two fuels and how this would affect the flow of each fuel. Alrighty, so now we need to say what that means is viscosity is all about thickness, so therefore biodiesel will have a slower flow through fuel lines. Okay, so therefore that's explaining and hitting this point about the fuel there. Now we've described it, we haven't necessarily explained why, and that's where I'm going to guess this 3rd mark comes from. So therefore, what I'm going to do is I'm going to explain why this is. You've been given a bit of background information here, but from your general knowledge, and from not your general knowledge, from your chemistry knowledge, you should be able to have basically a stock standard answer here about the structure of these two fuels. And 2 things is the fact that, firstly, biodiesel is a methyl ester. You should know that biodiesel is a methyl ester, which allows it to have dipole forces holding the molecules together. These are, again, this is a methyl ester. These will be stronger than the dispersion forces in petrodiesel. And looking here again, you can see the fact that the structure of petrodiesel is just carbons and hydrogens, which means it's dispersion forces because it's non-polar, and therefore biodiesel from your content knowledge is an ester. So that's one part of it. One other thing that they've actually mentioned in our preamble here is about the size of our molecule. So I might just also add in there, petrodiesel is shorter, which then, being shorter or smaller, means that its dispersion forces are also weaker. So that's quite a lot of writing for 3 marks, but realistically I think if you get these 3 dot points and you can try and break down the question into where those 3 things come from, you're very likely to get your full marks there. We'll have a look at the examiner's report in a second, and I'll come back to that as well. So let's move on, and let's look at this part here. And looks like we're going to have some calculations happening here because I can start to see the numbers. So assume that combustion occurs in an unlimited supply of oxygen for each of the following calculations, and use the data on table. So use this information here, and let's calculate the number of litres of biodiesel that are required to be burned to produce the same amount of energy as 2.5 kilograms of petrodiesel. Alrighty, so what's the information that we've got here? We've got energy content, and we've also got the CO2 emissions, but we're going to look at energy content. And if we need to produce the same amount of energy as that much petrodiesel, we're going to then work out how much energy that actually is. So the energy from petrodiesel equals, we've got 2.5 kilograms. Our energy content is this many megajoules per kilogram, so we're going to times that by 43. And that's going to be, again, let's turn this on, 2.5 times 43. So we're going to be producing 107.5 megajoules of energy. Now we need to then convert that into looking at how much biodiesel's being produced. So therefore the mass of biodiesel is, take the energy that you've got, divide it by how much energy is released per kilogram, and you're going to get your kilograms. So I'm going to take my energy and divide that by 38, because I know that's how much energy is released by 1 kilogram. So therefore I take my number again, divide that by 38. It's going to be 2.83 kilograms there. And that's how many kilograms of biodiesel I have. I've got the density of biodiesel here, so I'm going to need to use something to do with density. Now I can never remember density properly, but if I know that density is mass over volume, I can rearrange that to say volume equals mass over density. So therefore my volume of biodiesel is going to be equal to 2.83 divided by our density, which is going to end up as divided by 0.89 equals, alrighty, 3.179 litres. Now it's a calculation, so I'm going to quickly have a quick look for significant figures. I've got 2 significant figures here. I've got 2 here as well. So let's get round that into 3.18 litres. That's going to be how much biodiesel is going to be used. The second question here, calculate the mass of carbon dioxide which we produce from 3.91 kilograms of biodiesel. That's using, carbon dioxide. So this is how many kilograms of carbon dioxide is produced per kilogram of fuel. So if I've got, mass of carbon dioxide, this is an interesting one. I don't need to do any mole calculations here. I don't even need to think about a ratio of anything. I've simply got that much fuel, and this is how much is going to be produced per kilogram. So simply that times 2.52 is going to give me an answer. So therefore I go 3.91 and multiply that, multiply that by 2.52, and we're looking at biodiesel, aren't we? Just again double checking things. That's right. And that gives us 9.85. 1, 2, 3 significant figures on there, and that's going to be in kilograms. One thing to note is that if you are calculate the mass, we weren't given a unit. We need to include our unit here. Always nice to include units with whatever you're actually finding as well. So that's the calculation for that one. Good. Lastly, in some circumstances we have a limited supply of oxygen. That means carbon monoxide. Write a balanced chemical equation for the combustion reaction of the major component of biodiesel, which is this dude here, where carbon monoxide is the only product. So we're doing an incomplete combustion reaction here. So 1 is obviously writing out our reactants. That's going to be reacting with oxygen because it is combustion. That's going to form H2O and CO. And notice that it's CO because it's incomplete combustion and because the question actually tells you that. Then we need to balance up our equation, and we're going to balance it in the same way we do everything, which is carbon, then hydrogen, then oxygen. So we're going to start off with 19 carbons. Gives us 19 carbon monoxides. We've got 32 hydrogens, so what's that going to bring it down to? For water, that means it's going to be 16, because simply, obviously, H2, multiply that, you get your 32 there. Then we need to do some balancing acts with our oxygens. So on this side, I'm going to have 4 oxygens. On this side, I'm going to have 16 plus 19 equals, 4 oxygens, not 40. What's that, 35? Yep, that's fair enough. Alrighty, so therefore, if I just ignore that, as I say, I've got 2 oxygens there. I need 33 oxygens to come from my oxygen gas. So therefore, it's O2. That's going to be 16 and a half, isn't it? So 16 and a half oxygens is going to give me my balanced equation. This is most likely going to be in liquid form because it's a fuel. This is going to be gas. This is probably going to be gas or liquid, and this is going to be gas. So therefore, there's my full balanced equation for that there. Alrighty, so that's the end of that question, I think. Yep, so question 2 is done. Let's have a quick glance and see how we went with our examiner's report on this as well. So I've got the examiner's report here to have a quick look at, and these are again on the VCAA website. There's no secrets behind this. Basically every time an exam is put out, the examiner's report comes out shortly afterwards, after all the marks have come out, and it tells you the breakdown of the questions. Gives you an idea about what percentage of the state got the particular marks. So it tells you a bit about how, on average, how hard the question was. And the average for our part A of question 2 was 1.5, and that was out of 3. So 1.1 out of 3. So on average, most people got around about 1 mark there. The marks came from, let's have a look, biodiesel. One thing an examiner's report doesn't really show is what they're actually giving marks for, but if you look through it, you can kind of pick out the main points. It talks about having a higher viscosity, which is great, so it flows less easily. Yep, so it has a slower flow than petrodiesel. That's our 2 marks there. The vast majority of what this says is about our forces and the explain part of this question. So it definitely talks about the stronger dispersion forces because of the longer molecule in biodiesel. We talked about that in the other way, which is fine. Petrodiesel has a shorter, which means it has dispersion forces are weaker. That's still good. And the dipole-dipole attraction from the ester group we did cover there as well, which is good. This examiner's report tells you a bit about what kids didn't quite do as well. And that is, again, relating the structure, the viscosity to the structural differences. So it's looking at that application and I guess the higher order thinking in that question. Now let's have a look at the next one. We've got part B, examiner's report. Let's have a look at this. Here is our question. This question obviously most people got about 2 out of 3. So again, the average is about 2 out of 3. The question here breaks it down again into pretty much what we've done. We've got the energy produced from the petrodiesel, which we've got there. These guys give it in significant scientific notation. These guys give it in scientific notation. I generally don't. But Then I bring it down into the next part. We've got energy from petrodiesel, biodiesel mass, and then converting that into our volume. Looking at this, they've gone down to 2 significant figures. What have I done? That's a problem. That is actually 3 significant figures. I should have put that into 2 significant figures, which would have been 3.2 litres. I looked at it, I just didn't factor that in properly, which is quite annoying on my behalf. But well, you win some, you lose some. Still good to, that's why you look at the examiner's reports, isn't it? So you can have a look at what's going on. Next one was pretty straightforward. I guess the main issue probably with these 2 questions here, well, particularly in the second question, it could have gone down the route of looking at molar mass and things like that, and trying to do a conversion that you might normally have tried to do in Stoic. But this one was using a value that you probably hadn't seen before, which was the CO2 emission per kilogram, and understanding that anything that you have here, you need to read and understand what the value is talking about. Kilograms of CO2 per kilogram of fuel, and understanding how that might be used. It's interesting that this was only basically half the people got that mark for quite a simple calculation, but I think it's in thinking or overthinking a question sometimes, which what happens. One other aspect of that, it might be the fact that because units weren't specified, you might have had to put the units in there as well. So that might have been why this question may have come down in how people actually responded to it. Looking at this question, which is our balancing of our chemical equation, what have I done? Looks pretty good. H2O's first, doesn't really matter there. These guys are saying the gas or liquid, mainly because we haven't got the temperature conditions and they're not specified. We haven't got a delta H to go along with it, so therefore gas or liquid's fair enough. In general, hopefully there will be a couple of questions where I can talk about why you might prefer to use gas or liquid as your states for this particular type of combustion question. So that's it. That's question 2. And we should be pretty much right. Actually, one part here I just noticed there is this little comment. Students should be aware that fuels are supplied to diesel engines as liquids, and pretty much most places, most fuels in engines and things like that will be liquids as well. AQ or aqueous as a state, most things which are aqueous are not combustible. Even basically with an aqueous solution of ethanol is not really combustible. It has to be close to actually 50% ethanol before it actually does combust. So if you're ever doing combustion reactions, don't put in aqueous. So save aqueous to when you know water is actually present in the actual thing you're looking at. So interesting to look at that. All right, this has gone on for too long already. I can see I'm up to about 18.5 minutes. So I'm going to try and wrap that up, and hopefully the next couple of questions might be a bit quicker and I might not talk as much. But hopefully this has helped you. If it has, please feel free to comment below, or let me know how things are going, and subscribe to this channel, and you'll be updated when I do the next couple of questions. All right, cheers, bye.